We had a quiz today that went over the graphing of lines and of quadratic functions. So I want to use this as a review, and I hope this can be something from which we can build upon to be able to do this better in the future. Problem 1, find the equation of the line containing the points f of -3 equals 5 and f of 5 equals 1. So what these are really, this f of 3 equals 5, is going to be the 2 points, -3, comma 5, and also of input of 5, output of 1. So to analyze what we're going to do with this, I'm going to create a table, and this table is going to be in the form of what we call a 3-column process chart, where what it is, it's just a standard table, except that you leave yourself room in the middle to do some working out. And so the points -3, 5, here's -3 on the left side, 5 on the right, and then 5, 1. And what we have is our input value is x, our output value is f of x. So we can find the differences between each of these, the right side and the left side. So if we take 1 minus 5 on the right side, we get -4, and 5 minus -3 is 8. And so the m is going to be, I'm going to write this m, it's going to be x, excuse me, I already started out wrong. M is equal to y2 minus y1 over x2 minus x1. So the change in y divided by the change in x. And so in this instance here, we have m is equal to -4 over 8, which simplifies to -1/2. And now using the formula, which is the point-slope form, y equals mx plus b, we can just fill this in. Well, for 3, 5, we could also use 5, 1, either point. But m is -1/2 times x is -3, plus b, which we do not yet know, is equal to 5. And I'm just going to bring this below here. We're going to have -1/2 times -3 is going to be 3/2 plus b is equal to 5. And how many halves do we have in 5? Well, we have 10 halves. So if we subtract 3 halves from both sides of this equation, we have b is equal to 7 halves. So our equation in slope-intercept form is going to be y equals -1/2 x plus 7 halves, which is 3.5. And then finally, to graph the equation, if we go to our y-intercept of 7 over 2, that's going to be 3.5. We come right up here, and we have a rise over run of -1 over 2. So we go down 1 over 2, and we create a line, and this line will look something like this. And I wasn't looking for Michelangelo's Sistine Chapel perfection at all on this. But that's pretty much what it's going to look like. So if you were anything close to this graph, the last thing we can do is we can check our points. -3, 5, we go 3 to the left, up 5. Okay, -3 to the left, up 5. That checks. and then we have 5, 1. So we go up 5 to the right, up 1. So, let's see, 1, 2, 3, 4. Actually, it'd be right here. That's even better. So, pretty accurate. So that's problem number 1. Problem 2, graph the quadratic function f of x equals 20x minus 3 squared minus 2. Well, the standard form of a quadratic function, or not standard form, vertex form, is going to be this one. It's going to be f of x equals a times quantity x minus h squared plus k. So our vertex is going to be the coordinate pair h comma k. In this case, for our problem here, our vertex, we have x minus 3, so our h value is 3, and then k, or plus k, well, k is negative 2, so our vertex is 3 comma negative 2. And our axis of symmetry is going to be x equals negative h, or x equals h, excuse me, so we have x equals 3. So as far as the proper labeling, well, we have vertex of 3 comma negative 2, so I go over here to the right 3 down 2, so there's our vertex, and our axis of symmetry is going to be x equals 3. So we have the point 3 comma negative 2, and x symmetry is going to be x equals 3. Now, we have most of what we need here, 3 points for 7 points of this function graphed and a curve drawn through these points. Well, to do that, we can just create a table, and we have x, f of x, and we know our vertex is at 3 comma negative 2, so we'll put input of 3, output of negative 2. And to get our 7 points, we need to go ahead and add 1, so 4, 5, 6, and going the other way, we have 2, 1, 0. And because a equals 1, our step pattern is going to be plus 1, comma, plus 3, comma, plus 5. All right, so we're going to go plus 1, plus 3, plus 5. So negative 2 plus 1 is going to be negative 1. Negative 2 plus 3 is 2. And 2 plus 5 is 7. And then because of symmetry, if we come the other direction, we have negative 1 as an output for an input of 2. For an input of 5, we have an output of, an output of negative 1. For input of 1, we have an output of 2. And for input of 0, we have an output of 7. And we can kind of check this out with the equation, because if we have negative 3 squared, that's 9 minus 2, that's going to be 7. So that's going to be our y-intercept. So now we can just graph these points. We already have our vertex, and then we have 4 comma negative 1 and 2 comma negative 1. Then we have 5 comma 2, 5 comma 2, There it is. The other side we have 1, 2, and then we have 6, 7. So 6, 1, 2, 3, 4, 5, 6, 7. And our y-intercept is 7. So this is what our graph is going to look like with all the 7 points accessed here. So just something like that. Again, I'm not looking for perfection. Anyway, that's it. I'm probably going to get another quiz similar to this, and we'll probably test on this next week as well. So good luck, and thanks for viewing.